thanks for being here today. We really do appreciate it. We know you all are busy, and hopefully this will be something that will be of value for you. I have to start by telling you that I sort of live in a luxury position right here. The things that I'm going to be talking about may not seem, how do I put this, as lofty as some of the other presentations that you're going to be hearing today. I'm not talking about solving a big problem, but I'm talking about solving a very real problem for a lot of people who are faced every day with the problem of managing an infrastructure, and they're trying to figure out a better way to do that. So I'm not starting with the solution. I'm not starting by saying, well, we've got this project and we've already identified that machine learning is the way we should go. I'm starting from a different position. I'm starting from the position that says, is machine learning the right answer for us? And I think that one of the things that I have to be able to do is say no. If this is not the right solution, or this is not the approach to take, I have to be able to say that. And the reason for that is because a lot of the administrators who are taking care of the infrastructures today they're being inundated with buzzwords. It should be machine learning. It should be AI. We should get neural networks. We should get those things. And so as a practical matter, the people who are managing these infrastructures are saying to themselves, is this something we should be using or not? Does it make sense for us? And so I'm going to take it from a practitioner's viewpoint to talk about what we've learned in going out and talking to some of our customers, and what our customers are finding as they start to explore this, not as the data scientist and not as the higher level person who says, I want the answer to this big question, but from a practical viewpoint. And the reason I'd encourage you to sort of follow along a little bit with this is because in a lot of environments, part of understanding what this technology can do is to scale it down to a point that you can have something that you can get a real answer, an actionable answer out of. And that was the thing that we're trying to do here. We're trying to make what comes out of this be actionable. It's not just that we're going to get this result, it's that we're going to get this result, and so it's going to lead us to something. So one of the advantages that I have in going out and talking to customers and being in R&D is I'm allowed to ask stupid questions. I'm allowed to say to them things where they'll say, what's this guy talking about? This guy doesn't know what he's doing, because he's asking me some very basic questions. So everybody has a lot of data. Everyone shows you a slide like this, and when they do it, first of all, I should tell you as a person who comes from a storage infrastructure company, I love seeing slides like this, because what that means is you all get to buy a lot of my stuff to handle all this data. So from an initial viewpoint, you might say, yeah, that's kind of good news. But one of the dumb questions I'm allowed to ask is, hey, thanks for getting all this infrastructure to support all this. What do you do with all this stuff? Why are you collecting all this data? And so these are not my answers. These are answers that users actually gave me about why they're getting these massive data farms sitting out there. The first is somebody just comes along and says, it's required. Somebody passed some regulation someplace that said we have to keep this information around. And so it's strictly out there because someone told us we have to have it. We're probably never going to use it again, but we got to keep it. Okay, well that doesn't feel so good. Second piece is historic record keeping. What's historic record keeping? That's where, hey, I got this TV set and it broke. Okay, well, give me a serial number, I'll figure out where you bought it, and off we go. So that's going to allow people to go back and find out what happened, but generally those kinds of queries are going to be extremely pointed. I just have to look something up and I'll have the answer. The third part of this is, well, it's cheaper. I mean, you know this. You know this because when you go home on your personal laptops or your personal workstations and you look and you say, I've only got 10% of my disk space left, what do? You could say, I could either spend my weekends trying to figure out how to free up 100 gig, or I could just go buy some more storage, or I could go buy an external storage pack or something like that. And that's what we do because it's easier. And so what happens is we keep accumulating more and more and more data, but that doesn't necessarily mean that the data that we're keeping is doing us any good. And then the last piece is we can. I met some people that said, well, we just bring in more stuff and we can keep that capacity, and so let's hold on to it. And so a natural question comes back and says, well, why don't we try to do something with this data? And from a practitioner's viewpoint, just saying, hey, we've got all this data and let's do something with it, that doesn't help me do my job. Or put differently, unless you can demonstrate that it's worth my while to do something with this data, I'm not going to go through the exercise of this AI or this machine learning or anything else, because it's not really going to help me get anything done. So we had this device that was called an AMP. This is not, I don't intend for this to be a product plug. That's not what I mean. But let me tell you, you know those slides that you saw a few minutes ago that talked about this massive amount of information that's being kept by everyone every day. I can add to that. I can go out there and, by George, if you want me to generate data, I can generate data. Let me tell you what this device is. In the storage infrastructure business, I live in a very unique situation because a lot of the problems that are being solved that you're hearing people talk about today are for the end users. The types of problems that my customers are interested in solving aren't end user questions. They're questions like, for example, when one of you shows up and says, everything is going slow, what's going on? Or more specifically, is something broken? Or is something going on? Or I think that these machines over here are acting oddly. Can you tell me what to do to fix them? So these are very practical problems. These are cases where the customers are the people who are trying to manage the infrastructure so that the other customers can get the answers that they want. Now, sitting in the middle as I do, I see two levels of interest. The first interest is that you can almost think of the infrastructures that we provide as being like superhighways. Superhighways carry two different levels of information at two different levels. So, for example, the first thing is, if I'm monitoring the highway, I can tell every vehicle that gets on, what route that vehicle takes, and where it gets off. So that means suddenly I can be in the brokerage business of being able to say to somebody, how is this application performing? I can say, well, here's where your nodes live, because in this highly virtualized and containerized environment that we live in, especially with the advent of microservices, you can see that we're going to be getting more and more of these instances of trying to figure out what is living where and how is it behaving. So the first thing I can do is I tell you about the application, but the second thing I can tell you is about the infrastructure itself. So, for example, if I start to notice that something is heating up or it's drawing more power, I can say, following along with the highway example, I can say that I just figured out that one of my bridges is in a bad situation. I need to close that road to fix that bridge to get it repaired again. Has nothing to do with the transport of what's going over the top of it, but it has everything to do with making sure that that's a reliable transport underneath of it. And so as people come to these storage administrators, they're going to be asking them two kinds of questions. The first question is the very practical, is everything working the way that it should be? And the second thing is, what can you tell me about my applications? Because you can write them, but I can monitor them, and I can give them information about what's behaving. So we invented this device that was called an AMP. Some of you have these. And what happened is I could go in and I could capture information about every single transaction that's going across the infrastructure. I can tell you where every single piece of data comes on, every single piece of data goes off. I can tell how long it was, I can tell how long it took, I can tell how long it took for the storage to start responding to it. I can tell you all kinds of data about it. So the customer said, hey, that's absolutely great. What do I do with that? Because what you've just done is you've thrown me a whole bunch of data and I have no idea. Is this just historic? Is it transactional? Is this for warranty? Is this stuff you're going to look up? So they started to say, what do we do with all that data? Help us figure out what we should do. And all of a sudden, what this did for us is it helped us realize we missed the point. And the point that we missed here is that we were generating data for the sake of generating data rather than generating data for the sake of solving a very specific problem. So this started us out on this journey to try to figure out what is it that we can do so that rather than provide data, we start answering questions. And in figuring out what questions we want to ask, then we're going to be capturing the right data along the way. So, is there a solution in machine learning? Because every time you go into a meeting today, it's funny because I'm an old guy now, right? So every once in a while, I just hear we play buzzword bingo, and I can find out going into a meeting what are going to be the buzzword bingo things that come up during this meeting. And for a while, it was neural computing, if any of you remember that. And then we get into NUMA architectures, and then we say cloud, and then we say container. So we say all these different words, and the ones that seem to keep coming up now says, what about machine learning? What can I get out of machine learning? And the problem is that sometimes we use these words, as was discussed very appropriately in both Dr. Person's keynote a little while ago and on the panel, we use these terms, but we don't really say what they mean. Now that has kind of a double-edged sword effect on it. The first thing that it does is it makes it sound very complex. And so to someone who's trying to run an infrastructure, when they hear something like machine learning, it's like, I don't know anything about this stuff. And so there's a natural fear that comes out of this. But then there's the other side of it that says when people try to explain it, they try to oversimplify it. Even down to the point of explaining it in such a way that someone says, oh, really? Is that all it is? And if that's all it is, am I really going to be able to get that much value out of it? So the key to all this is that in order for us to be able to use the data, we have to figure out some way of synthesizing the right questions. And so what I want to do in the few minutes that we have left here is I want to tell you about what some of the questions are that you can ask realistically when you're talking to your machine learning data scientist. And you can say to them, can you solve this problem or not? And try to give you a little bit more background on what some of those reasonable questions are. But the solution has to be in the data. I loved when Dr. Pearson said the fact that you don't have to worry about the death bots getting too smart. Because a lot of times what we do is we put the emphasis on the machine learning aspect of it, instead of putting the emphasis on the fact that all the machine learning did was tell us something we already know but didn't recognize inside of the data sets that we only own. It doesn't synthesize data. I think that some of you may go out and you'll see artificial intelligence out there. This is actually kind of interesting. They wanted to give artificial intelligence the ability to be creative. And so you can go out there and you can find websites where they'll say, here is machine learning generated art. And here is machine learning generated music. And some of it was kind of interesting because what they did is they fed it samples of here's kind of the songs people like, and here's some art objects people like, and here's some that aren't so good. And it came up with some really good music and really good art, and some really bad music and some really bad art. So this is coming from a person who likes disco. So if I say that it was bad music, trust me, I know bad music, okay? And this stuff was just absolutely bad. So that means that what we have to do is accept the first parameter that says it's not going to be creative with data. Instead, what it's going to be is very good at telling us something about our data that we didn't already know. So in a previous life, I happened to work with a financial institution. And one of the things that happens inside of these for-profit financial institutions is they go out and they decide who they're going to loan money to and who they're not going to loan money to. And so you have these actuaries and these underwriters. And these guys make a lot of money for a very short amount of time. And the reason it's such a short amount of time is as long as you're advising the bank to underwrite very good loans, you're on staff. Man, you are golden. You get a good parking spot. You get all these benefits. But when you start having people sign for loans that aren't so good, you do that a few times and you're out. Exactly the same thing happens, by the way, in the stock brokerage viewpoint, right? That you can have a stockbroker and if they're hot, I mean, man, you're golden. But as soon as you start making some bad calls, you're out. So the goal here was, can we talk to some of the experts and figure out what it is that they do? Let's look at the data. Let's look at the loans that they approved and see if there's something we can pull out of that so that we can take two things. First, a less experienced actuary and give them this tool to say, this is a good one, this is a bad one, or at least an advisory system to go through and do a cursory analysis of these loan applications to figure out what are good ones and what are bad ones. And so the first thing is the tool to actually make the decision, and the second thing is train the actuaries. And so we started trying to look not only at the data sets, but also at the experts themselves. And what we found out is that the things that make an actuary good have nothing to do with the data set, nor can they be captured in the data set. So for example, if you've got, we said to some of these actuaries, how did you decide not to approve this loan? And by the way, as a side effect of this, which is something we figured out with expert systems, is the more you ask an expert how they do something, the more you're likely to break them. Like, for example, a perfect example of this, and this is why it's so valuable to have the information in the data. Suppose there's somebody, and I think you'll recognize who I'm talking about here. Suppose you have an excellent golfer. And this golfer can go out and is winning tournaments, and then you say to them, hey, you're the expert. You're so good at this, but I noticed that every time, just before you bring the club thing, I'm not a sports ball person, so the golf ball hitter thing, every time you bring that down, you slightly move this foot. Why do you do that? Guess what you've just done? You've broken your expert. Because the expert is going to sit there and go, why? I wasn't even aware that I did that. I mean, it was just kind of a fluid motion kind of thing. But guess what they're going to think about the next time they're swinging? All of a sudden now they're going to be aware of that and they're going to change their swing. In exactly the same way, what we found out with the actuaries is that once we started pressing them about how do you reach this decision, they couldn't tell us. And they tended to be not as good because they started overanalyzing things. And it could be stuff from as simple as it depended on what my mood was that day. Or I just read the front page of a newspaper and for some reason I got the impression that this wasn't a good time to take a loan like this. Absolutely fascinating to talk about, but what we found out is not only was the answer not in the data, it couldn't be put in the data, at least for the way that these particular actuaries were doing their work. So the lesson that we learned on this, as it applies to storage area networking infrastructures, is we have to start learning to ask questions that, first of all, can be answered by the data sets that we have, and secondly, can be answered by the techniques that we know how to do today and very well and scalably in machine learning. So what I'm going to present you is not going to be an exhausting list of these things, because I don't want to go through and give you a long litany. I just want to give you some representative examples, and I think that when you do this, you're going to find out that the answer to each one of these questions is inside of the data set. Now, the reason I care about this is because if I know what these questions are, I know how to go back and tell my customers, instead of just generating data for the sake of generating data, these are the data points I want you to capture because they're going to allow you to answer these questions. And if you don't capture them, then this will be the penalty. This is how you're going to penalize them. So, how do you go through the process, first of all? The way that you go through the process is by, and this is from a user viewpoint, not a data scientist viewpoint, you start by assuming that you've already been successful. And so now somebody has come in, this data scientist who knows nothing about your application, as we heard on the previous panel, they're going to come in and they're going to try to architect together some solution for you. And they've given you an answer. So the system's up and running. So the question you have to ask them is, what question did they answer for you? Or more specifically, what did the answer look like based on what the question was that you gave them? So, what are the questions then that machine learning is currently good at answering? Let me run through a few of these, and I don't want to get lost in the jargon. You have to internalize this in whatever makes the most sense for you. Binary classification generally says, is it a this or is it a that? And that's all I want to know. All I want to know. So, for example, one of the things that I want to be able to ask about the infrastructures that we have is this thing healthy? Now, obviously, healthy is kind of a hard thing to quantify, isn't it? That we've had a lot of discussions with customers where they say, I want to go out and I just have one metric that says if this is healthy or not. I don't know what that means. I don't know what, is anything, how do you measure healthy? And so what we had to do is we had to go out and start looking at the data that was available, and from that start to synthesize for each particular customer what their interpretation of healthy was. For some customers, healthy needs to be everything is up, everything is working. For some customers, health is measured by the ability to meet certain performance levels for their applications independently of what the current state of the infrastructure happens to be. For some customer, it's like, if I have a power supply that needs to replace, but I have redundant systems, is it healthy or not? So a big piece of this comes down to, when you say, is it healthy or not, what do you mean? And if you can define that, and if you're capturing the right information, then you can have this type of binary classification goes on. Interesting to note, by the way, the most common class of this is yes or no. That also means that you have a lot of examples of what yes looks like and what no looks like. The second classification here is multi-class classification. So think of this as having a bunch of, if you're a data scientist, I'm going to use the wrong word here, but it's very visual, so bear with me. Give me some grace on this. Which bucket does this go into? Because it turns out bucket means something, okay? So which category does this go into? Think about what this means. Suppose I have data and I happen to see some type of application that lives out there. I can say, see this particular flow? Does this flow look like one of my Office applications? Does it look like a database application? Does it look like somebody started up a torrent server? Does it look like somebody is doing something they shouldn't? Has something fundamentally changed in the way that this application is running to cause me to put this in a bucket called, I don't know what it is because it doesn't look like everything else? In a practical sense, does my network infrastructure look balanced? So I want you to put every one of my connections in 3 categories: underused, appropriately used, and overused. What does that mean? Multi-class classification, very powerful. Next is anomaly detection. This is kind of, well, and so this is kind of where you say to someone, does this look normal or not? Now this, when you first look at anomaly detection, you're going to say, Chip, you kind of messed up here, buddy. You got the same concept on 2 different slides. The difference between binary classification and anomaly detection is you have a sense of what things are supposed to look like. So for example, if I work in a department store, and I know what my sales have been for the last 5 years over the holiday season, and all of a sudden I start seeing wide swings in my data usage and my access and so forth, and it's starting to look like this, is that okay? And using something like anomaly detection, it's not going to say, well, I've trained it on a set that knows what's good and what's bad, but kind of looks like what it's supposed to, so yeah, it kind of looks normal. This is what you should expect for this time of year. So that's nice. So if you're faced in a situation where you're asking yourself the question, I think something is wrong. I don't know what it is, but something just feels like it isn't right here. Anomaly detection may be the way for you to go. There's also this idea of regression. The thing that's different about regression, and don't get intimidated by the name. In fact, it's kind of interesting when you go back and read the mathematical literature on this, and my wife has argued to me many times about the fact that, Chip, there's nothing interesting about reading the mathematical literature on this, but I think there is, so I still read the mathematical papers about it, and often giggle. So as you go back and look at this, what you find out is regression only means if I got this number for all these other situations, if I have this number, or this situation, what number should I expect? For example, if every other holiday season I've seen this much storage, how much can I expect to see this year given these fluctuations in the market? And then the last piece that I'll talk about here is this idea of unsupervised learning. Unsupervised learning says, I want you to help me not necessarily be creative, but just sort this stuff out for me. And I don't even know what I'm looking for. Just help create categories that I can put this stuff into. So the last piece that I want to leave you with is, can I trust the answer? Because a lot of what we've heard on this is you put the stuff in and you get an answer out. And even on the panels, I've heard people say, it's kind of a mystery. It's kind of a black box. We're not exactly sure what's going on here. Wrong answer. I have a friend who's working on doctoral research at a major university where they're working on driving a car, and their advisor has already told them, you know what, you may run this on 10,000 data sets and that's the way it works, but cars crash for reasons that we haven't seen before. You can't just say we ran it on these data sets and got the answer. So the way that we can get around this is by, excuse me, something that DARPA is already funding. Something with the idea of explainable AI. Explainable AI says not only am I going to be able to give you an answer, I'll be able to tell you why I came to that decision. Sort of in the same sense that we saw the decision trees previously. So watch that space, XAI, it's going to be very big. So what did we learn in summary? You have to start by knowing what it is you want to answer. And you have to make sure that the data that you have is going to be able to answer the question. So from a data collection viewpoint, if you don't know what you don't know, maybe you need to collect it all. If you know what you need to know, then collect what you need and don't worry about the rest. And suddenly making machine learning part of the solution becomes probable. Thanks again for coming in here today. We really do appreciate it. Very fast introduction, but appreciate y'all taking the time to be here today. Thank you very much.